Hi, I'm Christopher, and today we're going to be chatting about how SCCM exploitation looks in 2024. So, relevant expertise on my end. So, I'm the Chief Research Officer at MWR, like Dennis mentioned. I gave a talk at DEF CON in the US main stage 2 years ago about my personal research into how to break SCCM. It was a 5-year journey. If you want to see the outcome of me struggling with a lot of reverse engineering, feel free to go to the YouTube video. My story in cybersecurity really started in 2014. So I began as a consultant back in the MWR InfoSec days. My career took a turn to network security, red teaming, and specifically Active Directory, and SCCM was kind of just an offshoot of that. So kind of a bit of background about what our topic is today and why we would want to look at it. SCCM is effectively Microsoft's patch and they call device management solution for on-site machines. It's used to manage machines of all types. So whether we're talking about critical domain controllers, Exchange servers, or user endpoints, this is what you mostly use for on-site deployments. And yeah, it's gone through a bunch of logo changes. I flicked through a bunch of them. Right, so yes. 2 seconds. Yes, it's gone through a bunch of name changes over the years. They've now settled on Microsoft Configuration Manager, but I'm going to swap between all 3 names over the course of the presentation. Don't mind me. It's all talking about the same thing. SCCM research, why would we want to talk about this topic? I mean, I have spoken about this topic in the past. It's been included in our reports for a couple of years. Why would we want to talk about it again? This is kind of a site, a company called Secure Systems did a summary blog post about a year ago, summarizing how SCCM research has progressed over the years. If you look at that 2023 block, basically more research has come out in the past 2 to 3 years than ever before in the entire history of the product, which is relevant because it's still kind of the same code base. So these are things that have always been there, but the public knowledge about what's going on and how to exploit it and how to chain these things together is pretty much more well known than it's ever been. SCCM has been around for a long time. I mean, this is an email from Bill Gates in 1994 talking about the first release of System Management Server that customers were really excited for, apparently. And this is where it started. Nowadays, Microsoft is really making the push towards cloud. They're trying to kill off Configuration Manager as much as they can, to the point where they've now included Configuration Manager as a product into Intune, which is the cloud device management solution. And yes, I think if you look at what Microsoft's trying to pitch with all of their modern architectures, cloud is the future, except if you focus on that block on the bottom right, on my end anyway, there, where on-site domain machines that are only ever going to be joined to on-site Active Directory have to be managed by Configuration Manager. There is no other solution. So if we want to use Intune, we have to do something called hybrid domain joining, which is something that you can do for workstations, but you can't do for servers. If you want to manage servers, you can use this very niche product called Azure Arc. That's the only thing I can find that's cloud-based that Microsoft offers that lets you do device management for server machines, and that's trying to leverage kind of the virtual machine management tools that Azure gives, but push that down to on-site deployments. The issue with that is the vendor lock-in is kind of extreme. I mean, at this point, you're probably locked into Microsoft anyway because you're using Windows Server, but you might not be dependent on their cloud solutions, and Azure Arc tries to do the classic cloud pricing model of pushing down cloud pricing onto on-site deployments. So kind of a similar idea as, I believe it's called Azure Stack, which is the on-site version of Azure. Okay, I think the other thing that we need to consider when we talk about can we actually move away from SCCM is how do our environments actually look, and what is the cost of making changes, fundamental changes to the architecture, right? If Intune requires a cloud deployment, then we are really, in order to kind of deprecate something like SCCM, we need to move our entire environment into the cloud. Now, that might be possible for a new startup, but if we're talking enterprise scale, we probably have legacy apps or legacy systems that our business is reliant on, that runs critical business processes, and the cost of, changing a device management solution is really the cost of redeploying so that you can use that it's in a supported configuration so that you can use it. And a lot of companies have gone down this journey of digital transformation, which 100% is a nice initiative, but I think there is a difference between saying that we're going to move our email servers and saying that we're going to move our core banking system that has some kind of integration with Active Directory, is sitting on a mainframe that doesn't really connect up super well. So really kind of the big picture there is, as much as Microsoft might want to push you in a certain direction, it's worth considering the architecture that you're using for your critical systems and whether that fits the model that they're trying to sell you. If it doesn't fit the model they're trying to sell you, we need to work with what we have, which means we need to understand what the attack is, what the attacks are against the stuff that we need to use from a practical point of view. So yeah, it's probably worth understanding what the attacks against SCCM are. So if you go looking, you come across something like this, which is a list of all of the different SCCM resources that these guys have compiled. So this is, I'll talk about this more later, but this is a project from Spectre Ops called Configuration Manager that has a resources page that lists everything that they know that's ever been published about it. Pretty overwhelming if you don't know where to begin. So that's what this talk is trying to address. I'm trying to make this more accessible. One last note before I begin. So I have personally contributed research in this space, but as you can see, there's a lot of stuff out there. Most of what I'm going to be talking about today is not my own personal research. And I have kind of put screenshots. I'm trying to give references to the original authors where possible. Yeah, go read the original source material. The guys deserve credit for it. Okay, that being said, let's dive into what practical attacks look like and kind of what architectural concepts we need to understand in order to understand why these attacks are possible. So yeah, first step, let's start off with, the point of device management. We want to manage a device, which in SCCM world is called a client. So this is a machine that has an SCCM client, the SCCM client software installed, and it will talk back to some central machine to pull policy and to pull software in order to deploy applications, allow people optionally to download applications and then push configurations by changing registry settings, running scripts, pushing credentials into memory, weird stuff sometimes. But yes, the point is we ultimately want to manage these endpoints so we have some kind of agent on them that talks back to our SCCM server aspect. The main server aspect in SCCM is what's called a primary site. So an SCCM site is kind of like the main collection of all of the different features that we want to switch on in order to manage our single deployment of SCCM. A primary site is the minimum set of features that we need to at its base, it's the minimum set of features that we need to have a running SCCM deployment. So this would at least be something like a site server, a database that site server uses to store data and manage configurations. And then there's a couple of extra roles that it uses in order to support core features. So something like a distribution point is used for pushing software, so hosting the software so that clients can download the software. And a management point is a role that supports effectively pushing policy down to the clients. So that all of those things would be included in a single primary site deployment, because that's the minimum set of things that we need in order to unlock the features that let us manage clients. Now, in this picture, we have two primary sites. What if we didn't want to log into those primary sites separately? There's another SCCM role called a central administration site. So we can actually hook sites together under a central administration site so that we have a single pane of glass that lets us access all the different primary sites and configure the different primary sites. And then finally, so it's worth noting the central administration site is optional. Otherwise, it would be included inside a primary site. And then a secondary site is kind of the additional feature that SCCM supports, where let's say we're running a remote office over a 56K modem. We probably don't want every client in there to pull every single software package over our 56K modem internet connection. So we might deploy a secondary site that sits in that remote location. So the download happens once to that secondary site, and that secondary site will then host the policies and the software closer to the clients that need to access it. And this all together, so this whole picture, because everything is hooked together and it's related, is called an SCCM hierarchy. And the hierarchy is the security boundary of SCCM. So I think one of the first things that we can probably understand from an SCCM perspective is, because we've created a hierarchy, one of the things that you might think is that these primary sites are separate from each other, and the admins on one primary site can't see information on another primary site. But because we've hooked them together using a central administration site, they're now part of the same hierarchy. And because they're part of the same hierarchy, administrative rights are shared between servers in that hierarchy. So if we extrapolate this to something like Active Directory, the classic line is the Active Directory forest is the security boundary, not the domain, right? So the hierarchy is the forest here, and each site can be seen as a domain. So if it's in a parent-child structure, so a hierarchy, then every single component in there technically has admin over every other component. That also applies a bit counterintuitively to the secondary sites to primary sites. So primary sites can compromise central administration servers or sites, and then secondary sites can compromise primary sites. So you can jump around if you've got a hierarchy. Okay, then let's talk about just quickly, we've already touched on a couple of different roles and why those roles exist. SCCM has a lot of complexity around configuration. As an example, so I'll quickly go through this. This is just Microsoft's page on how to configure SCCM. So I'll just stop at this highlighted block here. So you see this line says computer account as administrator. So this is specifically talking about the central administration site, but it doesn't matter. There's lots of different roles that have similar types of permissions. So this is effectively saying that the computer account of the central administration server needs to be an administrator on the primary site server. So that means the computer itself, not the users that log into the computer itself needs administrative rights. The one that's most commonly exploited, and I think I have an example of it, sorry. PowerPoint and media is not the not the best thing. So I'm just going to wait for this to play on. But if you scroll a bit more down, effectively sites also need administrative rights on other servers that are part of the site. So I think the one thing, so yeah, you'll see that line that's highlighted there. The computer account of the parent primary site needs sysadmin permissions on the instance of the SQL server on the secondary site server. Now, it doesn't need to be deployed like that, but effectively, this means the computer account of the primary site needs sysadmin rights on the database server. Now we're starting to see, because these don't all have to be deployed on the same system, they can be on physically separate servers, which we are probably interested in doing because we want to make sure that these run efficiently. So we want to make sure that SQL is on its own instance, because then we can properly give it the necessary prerequisites to run the amount of clients that we want to run and do the storage that we want to run. It's a very common architectural deployment to put these things on different physical servers. But as soon as we do that, now we're starting to give computer accounts admin rights over other computer accounts in our Active Directory deployment, which is fine for SCCM, but when we hook that into attacks that are common against Active Directory, SCCM starts to become this, this product that has inherent architectural issues because of its deployment requirements. Okay, so let's talk about some of the other deployment considerations before we finally move on to showing what this practically looks like. So I've already started down this point, but SCCM has a lot of interaction between the infrastructure and the application, right? I think a common way of thinking in terms of systems architecture is that the infrastructure is usually separate from the application, right? We can do a secure build of the infrastructure, give that over to an application team, and that they can't use that to compromise the rest of our environment. Because SCCM is a device management solution, it inherently has rights over the rest of the environment, right? That's the point. It's supposed to manage workstations. It's supposed to manage servers. This is how we push software. So inherently, especially if we consider that point around hierarchies, let's say we want to do things like Active Directory tiering. Really good practice. We only want domain admins to log on to domain controllers. Great. Only domain controllers then host those credentials, so we can't use that to compromise the entire network. Unless SCCM there's an SCCM client on the domain controller, in which case our SCCM admins suddenly have administrative rights over our domain controllers. And that means any attacks against SCCM are also attacks that can compromise the domain, right? That's just part of the architecture. And similarly, it goes the other way, right? Where if we compromise, if there's an Active Directory vulnerability that gives us administrative access to any of the SCCM servers, we can probably turn that into an SCCM compromise, which gives us a compromise of the environment. I think one that's of particular note is the relationship between the database server and SCCM itself. Because SCCM is effectively just a front end to a SQL server, if you have administrative rights over the database, so not even the database server, the database, you can turn that into rights on SCCM, and then that will then become an infrastructure compromise. Like one common thing that I've seen in the past is that oftentimes in large enterprises, you have a DBA team, and that DBA team is given administrative access to all SQL databases in the environment. That can be a good thing from like a data management point of view. These are the people you trust. You want them to be able to debug issues when they happen, that kind of thing. However, the problem with that is if our DBA team is not supposed to have any infrastructure access, if we give them access to the SCCM database, they can turn that into infrastructure access, just inherently. And that also means that then we need to treat their creds with the appropriate level of care that we might apply to our infrastructure admins. If we then try to say, okay, let's lock down some of the features of SCCM, like we only want to use a certain number of features and we want to use something like network firewalls to block protocols, we need to understand all the different protocols that are in use in order to make SCCM function. And that can be a lot less obvious than you might expect. So as an example, just from a couple of the blog posts I've read, we're dealing with at least SMB traffic, WMI traffic, HTTP traffic, and in some cases, WebDAV. There's obviously MS SQL for our databases, and then if we're using Pixie, there's DHCP and TFTP. So each of the different features might use different protocols in order to communicate. And if we were trying to use, let's say, network restrictions to lessen the attack surface, we actually need to know what those protocols are and which servers need to talk to which machines in order for the product to function. And then I alluded to this already, but kind of the relationship to other security initiatives in the environment, right? If Active Directory tiering is our thing, we want to make sure that administrative rights aren't being sprayed across our environment. SCCM is an integral part of that because it manages aspects of the environment. So is SCCM itself a tier break in your environment in that, you know, let's say tier 1 admins are managing SCCM, but they manage tier 0 infrastructure or tier 0 adjacent infrastructure like Active Directory certificate services, domain controllers, maybe ADFS, that kind of thing. So there's a lot of complexity in terms of how we deploy it and then how we configure it in order to make sure that it doesn't undermine what we're trying to achieve with other initiatives. Right, let's get to the practical stuff. So let's chain some public techniques together to show how this might come together in practice. I'll mention this again because I think this is a really good resource that came out this year. So the Spectre Ops team that I was fortunate enough to meet while I was at DEF CON in 2022, they put together a project called Configuration Manager that has a list of all the different resources and groups the different types of attacks against SCCM into a kill chain of sorts. So this is just a extract of what they put together, but as you can see, it kind of maps onto the MITRE attack framework, and they've put different types of attacks under each of the different sections. So just at the top there, it's on GitHub. Subatomics, I think this is Dwayne, I can't remember his surname, but it's Dwayne at Spectre Ops. He's the guy that's hosting this, and a couple of people there put this together. So let's dive into how do we use this in order to perform an attack. So if we focus on, let's say, discovery, like one of the key things as a practical attacker looking to exploit this, one of the hard things is where are the SCCM things? Where are the servers? How do I find them in order to target them? What rights do I need in order to start targeting them? As you can see from this, most of the attacks against SCCM are authenticated, so you at least need low privilege domain access. This means you need to be running on someone's machine as a low privilege user, or you need credentials in order to do that. The one exception is my research. So you see I'm the only one under initial access. The Pixie credentials, there are certain deployments where you can just plug into the network and just get credentials that way that are potentially privileged depending on how SCCM is configured. Definitely something to be to check and audit to make sure that the credentials you're deploying as part of your Pixie deployments aren't overly privileged. If you haven't, would highly recommend. But yeah, let's look at the other authenticated attacks for these examples. So one of the examples is something like this, where when we deploy SCCM, we can configure information associated with SCCM into our Active Directory LDAP structure. So we can query it in order to get information. So like this, we're querying something called MS SMS management point, and that gives us the FQDN of the management point server, which gives us a nice target because this obviously needs administrative access over other servers in the environment. People have taken this to another level. So one of the other members on that Spectre Ops team called Garrett Foster, he put together a tool called SCCM Hunter. It kind of looks like this. Maybe let me start from the beginning. 2 seconds. Okay, so I'm running it in debug mode here so that we can see what it's doing. And some of the techniques are fairly simple, right? All we really want to do is identify anything in Active Directory that has anything to do with SCCM. So let's look for accounts that have CM in the name, or SCCM in the name, or MECM in the name, or MCM in the name, any servers that have that in the name, perhaps things like looking at the that LDAP container and what created that LDAP container. And once we've done all of that, then we can kind of get a list of at least a starting point for this is some stuff to look at. I'd say one of the harder things to identify using this technique is what is the SCCM database. One of the tricks is if you can identify the account it's running under, you can look at the service principal name to see in Kerberos, where has it been registered for authentication? So in here, there's a SQL account called SQL SCCM service, and there's an SPN that points us to the database server. Right. Okay, this is going to restart again. Cool. So just skipping ahead. We can then also, now that we know where some of the systems are, we can directly probe those systems to try and understand what is the configuration and what role does it take in SCCM. So here we're just pointing out this is a distribution point, this is a SQL server, this is the site server, that kind of thing. Then we can cross-reference that with the prerequisites page, and then where it says things like this computer account needs admin access over the database, then we have our targets to try and abuse things like NTLM relay attacks. So rather than preempt it all, I might as well just show you what this looks like in practice. So this is a full attack chain. Now that we've done that reconnaissance, we know where all the servers are. If we run this attack, this is just redoing the information gathering, pointing out that we know where the SQL server is, then running a command with SCCM Hunter that abuses the fact that if we have administrative access over the database, we can turn that into SCCM admin. So that's the command. If you were interested, that's the command that you can use to do that. This obviously just automates some of the more manual parts, like turning a username into a SID in order to properly write to the database. Then if we continue, we can, this is just showing that when we start, domain user is not, sorry, this media bar is a bit in the way, but that domain user doesn't have admin access, right? It says access denied. Then we run NTLM relay X, which is effectively just going to be, we're using a Kali, attacking Kali machine in order to relay authentication attempts. So this is just saying, when you receive an authentication, try log into the SQL database and run that command. I ran that in a screen, so that's going in the background. And then we use Petit Patam, which is just, so a couple of years back in 2018 or so, Spectre Ops released a talk called, I think it's something like the downsides of trusting Active Directory or something. And as part of that, they disclosed a bug that became known as the printer bug. But effectively what it could be used for is you can talk to a machine and then tell it to authenticate to another machine. which is not terrible, other than the fact that Active Directory uses an authentication scheme called NTLM, and NTLM is vulnerable to these kinds of relay attacks, unless you enable very specific security controls to protect against it. So ever since 2018, this is all just putting it together in one video and showing how it specifically applies with publicized techniques nowadays, but we've been abusing this attack path since 2018, ever since that talk came out, because I knew about the link between a site server and a database server. This is a Petit Patam builds in a couple of different, they're called coercion techniques, so trying to get a thing to authenticate to another thing. This doesn't use the printer bug. It uses something called EFS, so encrypting file system. Microsoft has said that they can't fix this, that it's part of the protocol that you can coerce this authentication. So this is kind of then taking the fact that we can make a machine authenticate to any other machine, linking that together with NTLM, allowing for relay attacks, and then the fact that the security controls aren't enabled in order to then, if we go back, is this going to start? No, it's going to restart. Oh well. Can I skip ahead? I don't think I can. Let me try quick. No, I'll start from the beginning. Just let it play in the background. Okay, so by chaining those three things together, we can then coerce authentication, authenticate as an admin to a target system, and then compromise that system with the rights that we've coerced. Because it's a machine account, we have a built-in way of always, if we have low privilege access to the domain, we can make this happen with something like Petit Patam. SCCM is not the only application that has this vulnerability. This is why you should be particularly careful when granting a machine account administrative rights to another machine account, because this is the attack path. So now that we're here again, if we go back to NTLM Relay X, we see that the relay happened, and we logged into the database. It was successful. We ran this command, and now that we've ran the command, if we rerun that check to see whether we're SCCM admin, instead of getting access denied, it just lists us as having full admin to SCCM. And once we have this, we can create scripts, we can create custom software, and we can push that down from the SCCM servers to other machines. It's also worth noting SCCM is just another server in Active Directory, and oftentimes the people logged into that server are very privileged. So if you have administrative access to the SCCM servers, you can log into them, you can dump out the credentials for other people that logged into them, and you can use that to pivot just like any other application in Active Directory. Okay, so kind of to conclude this section, I did want to raise some of the things that I found out while prepping for this talk. So I did watch the conference talk that SpectreOps put together, discussing and introducing Misconfiguration Manager, and there was this really interesting line: Microsoft is collaborating and taking this seriously. Question mark, what does that mean? So I reached out to Chris Thompson, who's the third member of that SCCM team at SpectreOps, and he told me that they met with the SCCM development team while they were in America, and there's no timelines, but they're obviously, because this is baked into the product, right? This is installing SCCM in your environment in a specific way, allows for relay if you haven't protected against relay. They're trying to make changes to the product and release a future update that automatically builds in some of those protections against coercion attacks. So hopefully that's coming to an update near you. All right, summary takeaways. Effectively, I think the thing to take away is these techniques are more public than they've ever been, and more people are looking into it than ever before. SCCM is a really old product that does make use of some really old architectural decisions. That doesn't mean it's inherently broken. It means that we need to understand what the attacks are in order to make sure that it's configured properly. Something like Misconfiguration Manager is a good thing because it's a public listing of all the different attack techniques and ways to defend against them. Obviously, I've also written up, for my research, I wrote up a configuration advice for how accounts should be configured to make sure that you can't steal credentials, or that if you do steal credentials, the impact is not as severe as it could be. I think it's worth noting that if you're doing network testing nowadays and you have an environment that has SCCM deployed, it is worth expecting the people testing your environment to test for this. And it's worth informing SCCM deployment teams and those admins that work on the configuration about these things so that they can start incorporating checks for the key things that cause vulnerability. I think because most Active Directory environments still have NTLM enabled, it's a big undertaking to disable it. It is worth going one of two routes. Either everything that accepts NTLM authentication needs to enforce some kind of signing control. So in more traditional pen testing circles, this is called SMB signing, but SMB signing is not the control. You can't switch on SMB signing and disable relay. Relay needs to be disabled, or NTLM signing needs to be enforced for every service that accepts NTLM authentication. So MS SQL, LDAP on Active Directory, HTTP, SMB, WMI, all of these things need signing controls enabled. SMB signing covers a couple of them because some of it is just baked into the SMB protocol, but it's worth reviewing all of the things on SCCM that accept this, and then making sure signing is enforced. Suffice it to say, if you haven't enforced SMB signing in your environment, the 10% performance hit is worth it. Please do that. As long as NTLM is enabled, this is an issue. I think another thing that we can draw from this is computer accounts having admin access, even if the application developers tell you to do it, is a bad idea architecturally in Active Directory. It should be reviewed, or you should at least know about it so that you can watch for authentication attempts using those accounts where coercion is being abused. And Microsoft is slowly getting to the point where they're trying to disable NTLM entirely in Active Directory. It is a really old authentication protocol. It was made started out in the, I think, late 80s or early 90s, got some revisions as the cryptography got bad. The cryptography is not terrible, it's not great, it's a fast algorithm to crack, relatively speaking. But Microsoft is making steps to, well, they have deprecated it from the authentication team anyway. None of the product teams have made this happen yet, like SCCM is one example. But Microsoft is eventually moving in that direction. So it's something that should be on your radar, which is having your team start to investigate what the impact would be to actually disable NTLM. What does it break? Because it probably will break things, and it probably will break Microsoft things still. But that is the general trend of where things are going. I think like the one big takeaway, the one really non-obvious attack path here is database admins have infrastructure access to SCCM. Make sure the database administrators of the SCCM databases are the people that are administrating SCCM and no one else. Otherwise, you have unintended attack paths. Don't use everything in SCCM if you don't need it. More features equals more attack surface. And yeah, updates are apparently coming. Keep your installation up to date. Make sure you keep up to date with things like Misconfiguration Manager. Might be worth including a Google alert for SCCM exploit so that you can be aware of new techniques that come out. But there's definitely stuff here. I do think more stuff will come out, given the general trend. Probably more tooling because it's so useful for pen testers and attackers. So there's decent work that can be done there in terms of both defense, prevention, detection, and response. Right, thank you.